Good morning to my lecturer Encik Abdul Aziz and my friends. My name is Lee Shin Hong and my machine number is 01DKM20F1070. Today I would like to present a 3D model for my course DJJ30122 Computer Aided Design. First and foremost, the 3D model that I will be presenting today is a Trishaw. This Trishaw is created based on the design of pinning Trishaw. Now I would like to present about the background of the application, which is the Inventor, and the history of Trishaw. Autodesk Inventor is a computer-aided design application for 3D mechanical design, simulation, visualization, and documentation that are developed by Autodesk. Autodesk is an American multinational software corporation that makes software products and services for engineering, architecture, construction, manufacturing, and other industries. Inventor allows 2D and 3D data integration in a single environment, creating a visual representation of the final product that enables users to validate the form, fit, and function of the final product before it is even built. Unlike other 3D systems, Autodesk Inventor is a parametric and feature-based system that allows engineers to create 3D parts, assemblies, and 2D drawings. A Trishaw is a bicycle with chassis, powered entirely by the cyclist. The Trishaw was a popular mode of public transportation in the intermediate years following the end of the Japanese occupation in Malaysia. As you walk around Georgetown, Penang, you may see Trishaw passing by. This mode of transport used to be very common. Now, the Trishaw riders are primarily involved in the tourism trade. Penang Trishaw have the cyclist behind with the passenger in front. This is different from other locations where the rider is at the side, such as the Trishaw at Malacca. Now I would like to present about the parts of the Trishaw. First, I will share the isometric drawing, and second, I will show the step and how I use the command to create the parts in the IPT file. Okay, for the first part, which is the axle, this axle is used to connect the tires on the Trishaw. Okay, first I will create a sketch. This is a circle with a diameter of 20, and then I extrude. After that, I create a real thread at the both ends. Rather than just simply use the thread command, you can see there is a difference. This is 01, and this is only a marking, like mark on the surface only. Okay, I will show you at the end of the presentation how I create real thread for my component. Last, I use fillet to smooth the edges. That's all for part 1. For part 2, which is the bearing, this bearing allows the tire to rotate. Okay, I will enable half section view. First, I also create a sketch. This is the sketch for the casing and the internal bore. Then I using the command revolve to create a casing, inner casing and outer casing, and also for the bore. But there is some difference. For the inner and outer casing, I pick the axis of jack. Okay. Then for the inner bore, I pick the axis of the center line of the bore. Okay. Last, I use the circular command, which is this circular command, to create other bores. Let me end the section view and section view, then home, front. You can see the other bores are created by using the circular command. That's all for part 2. For the third part, which is the bicycle frame, first I will sketch for the outline of the frame.
You can see this is the outline of the frame. Include the angle. This have angle. This also have the angle. Then I will locate a plane, a new plane. You can see this is all the plane at the end of the line, and then start line sketching. After sketching, I will create extrusion. You can see all these tubes are the extrusion are created by using extrusion. I use shell command to create the holes in the tube. Also here, also in, and here. At the end, this part also created by using a sketch. Let me on the visibility. This is the sketch, and I use extrude to create the part. And I also created a work plane for it before I start the sketch. You can see it is in the middle of the tube. And then for the other side, I use mirror to create it. That's all for bicycle frame. For the bracket, it is very simple. Just create a sketch and then extrude it. And the last one, I use fillet to smooth the edges. That's all for the bracket. For chassis connector, it's also the same. First, I start the sketch, and then I use the command swap. So here is a plane that I place, and then I start sketching. Then I pick this rectangle and pick the part that I want, which is as the center line, to create the tube. For the center rectangular bar, it is simple, just using extrusion, and also for this part, it's also use extrusion to perform it. Then I create holes. There are many holes on the chassis connector. Okay, it is used to connect with the chassis. This hose is used to connect with the stand. Okay, for the chassis, it looks very complex, but it is same as previous. First, start the sketch, and then I extrude it for both sides. I use this command to create the line. First, I located some points and there. Here is the point, here is the point. I use this to locate the point. Then I use this command to join all the points. Okay, you can see each point have its coordination. Then I will create some screw hole and the holes for the axle to pass through. You can see from here. This hole is the axle pass through and screw holes for the mudguard support. This also screw hole. Here is where the handle will insert into it, and this part is to connect to the bicycle. Then I also fillet the edges to smooth it. At the bottom, it also has screw hole. This is used to connect with the chassis connector. Last, I create the seat, also using the extrude command. That's all for the chassis. Next, for the connector. This connector is used to connect the chassis, which is located at here. It may be located at here, connected with the bicycle frame. So, in this part, I use revolve. I only create a sketch at here. Then, I using the command revolve. But it is special to mention that I project the whole bicycle frame so that it is perfectly matched the dimension in this tube. Let me show you how I bring the bicycle frame used as the surface in this IPT file. First, I use this derive, and then you will bring the part bicycle frame and open. Okay, then I pick body as work surface. That's all for the part. For the handle, rather than using a 2D sketch, I use 3D sketch to create this part. Okay, you can see that this is a 3D sketch. And then, this is a 3D sketch. And then, I place a work plane at here. So, I only create one side of the part and then I mirror it to the other side. I also use the loft command because I sketch a circle at this work plane, and then here is some angle, this angle, so I'm using loft for the handle. That's all for the part. For the holding pin, it is inserted into the connector. It's also the same. I am using extrude command and then create a real thread for the part. But I also create a feature for the pin. So I will show you how I create this. I create a circle and then I extrude it negative 45 degrees. Let me show you. Okay, this is the circle that I pick, and then I use cut negative 45 degrees and OK. You can see that there is some difference if I delete it. Okay. And here is flat. Here is flat. Does not have any angle. But I undo it. The angles, the edges at here. Okay, that's all for this part. Thank you. For the inner chain, first I will create a work plane which offset from the YZ plane. You can see here, offset from the YZ plane. Okay, and then I create a sketch on this plane and extrude it. Then I mirror it with YZ plane. This is the mirror one. So I only create one of the side and the other side is mirror. At the center, I extrude. Then I fill all the edges. That's all for the part. Okay, for the M6 bolt, which is 15 mm long, first I create a sketch for the head, and then I extrude it, and then I create a real thread for it. So here is some edges. I cut it, and I will show you how I perform it. First, create a circle, and then pick intersect, and then 45 degree, and OK. Then the edges is here, same as the top one. And then this is the real thread. At the end, I also have a 45 degree cut. You can see here, I use extrusion, I use extrude, and then cut negative 45 degree, then OK. So here is the feature here. That's all for the part. Next, for the M6 bolt 20mm, there's nothing different from the 15mm, so only the length is different. So how I perform it is also the same with the M6 50mm bolt. That's all for the part. Now for the M6 nut, first I will also create a sketch for it, and then I extrude it. But I will show you how I create this feature, these edges. I use extrude, but first I create a sketch. This is the sketch. Just only the circle and tangent to the edges. Then I use extrude, use intersect 45 degree, so you will get the edges, and OK. Same as the bottom part, use intersect and 45 degree. And for the inner one, this is also cut by using extrude. So same, start a sketch. So diameter I put 6. And finish sketch, then extrude it. OK, now I pick cut negative 45 degree, then OK, and you will get the edges. You will see a difference if I delete it. OK, here is the surface while I undo it, and here is the feature of the edges. Same as the bottom part. OK, that's all for this part. For the M11 nut, it is same as the M6 nut. Nothing different. Also, here have the feature of the edges. They also performed by using extrude. OK, and I create a real thread inside the nut. So there is nothing different from the M6 nut. That's all the part. OK, for the Mudguard support, you can see that here is not a flat surface. Here is a circle which have radius, so have outer radius and the inner one. Inner one is here, and then I will create a circle at here center and make some screw hole inside it, and fillet the edges to smooth it, and also fillet here. This curve is created by using fillet, and here also. And here I have the screw thread, which allow the screw to screw into it. Okay, I think that's all for this part. For the mudguard, first I will create a sketch, and then here is the sketch, and then I use revolve it. I also fillet the edges. This is the edges I fillet. Also located the screw hole at here. Also at here and here. Then I will fillet here also. So it is a circle with radius. So this is the inner radius and this is the outer radius. And these edges is fit into the mudguard support here. That's all for the mudguard. For the outer chain, it is same as the inner chain. So first I will create a work plane which offset to the YZ plane. Then I start my sketching on this plane and I mirror it. Before I mirror it, I extrude it. Then I will extrude for the center one, this pin. Last, I fillet all the edges. That's all for this part. Okay, for the pedal, first I will create this circular. Then I extrude for the rectangulars, the 3 rectangulars, and for the right side and the left side. Then I will create this feature. This surface is created by using fillet command, and this triangle is created by using the extrusion. And then I only mirror to the other side, so I only create for this side only, and then I fillet it. So here is the edges I created by using fillet. It is radius 5. Okay, it is radius 5, and then it's the same as the other one. Then here is also the fillet, and I apply some colors on it. This is the color that I apply, which is a yellow and a red. And that's all for the part. For the rain shell frame, okay, this frame is created by using 3D sketch also. You can see that. I turn on the visibility. Here is a 3D sketch, and this is radius 150 for both sides. And then I create the pin here. This pin is used to hold the rain shield. And this, I also create a real thread here. This is used to fix the nut. Here is the rain shell handle located, where you can see it at the end of the presentation, which is the animation of the assembly. Then this circle I use extrusion to create it, and then fillet the edges. That's all for the part. Okay, moving on to the next part. For the other one, which is the rain shell frame tool, there's nothing different. I also use 3D sketch, and then also radius 150 for both sides. The only difference is here become 2 holes, which this frame will located in the middle, and you can see this is only one hose, and here is the thread and the holder. Well, this only have a pin for the rain shaft. Okay, that's all. The procedure that I used to create this frame is also the same as the previous one, which is this one. So there is nothing different. Next, this is the pin used to hold the rain shaft holder or the bracket. Okay, this I create a real thread at here and fillet these edges and also these edges. This is also using fillet to create it. Okay, also first I start a sketch and then extrude and then fillet and I create a real thread for it. That's all for this part. Okay, for the rain shaft I created here, you can see this is the rain shaft, but I want to share with you that how I created, because it is more difficult to create rather than other parts. First, I will project the surface. Let me turn on the visibility. You can see this is the assembly file. This part is the assembly file, which located in here. So you can see here has 5 frames and a bracket, second bracket. Then I save it, move to the IPT file of the rain shaft, and also the same, manage, derive, and I pick rain shaft surface, which is the assembly file. I name it as rain shaft surface. Then I open it and then I use as surface. Okay, then you pick OK. Okay, here you are. Okay, now I will show you how I create this rain shaft by using these surfaces. First, I create this sketch, and then I enable half section view for the work plane 1. Okay. So you can see that this rain shaft, which is a solid, is loft by using this center line, and this center line. All center line have its radius, and last, this straight line to the below. Okay, then I create the planes in between the frame. Why? Because I need to create this sketch. You can see that graphic. You can see that this is the thickness of the rain shaft. Okay, this bottom line is projected from the frame, and I offset it for 2 mm. So I did it for every frame. Why I did so, I will explain later. So now I finish sketch. Then I turn off the visibility of the work plane. So I use this as the example. I create this sketch and this sketch. Okay, this sketch is the outline of the frame, and then I use loft. I use loft to create. You can see that I use loft to create the ring shell surface. I pick sketch 17 and sketch 18 and it will create a solid. OK. For the second one, this surface, you can see that I'm using the center line which I created. So I pick this profile and this profile, then I pick the center line here, then it will create for me. And I just repeat it for the other one. Also the same as the last one. The last one also using a loaf. Okay, and last one, I create the holes for the ring shell so that it can locate it in the ring shell frame. Here I have 3 holes, and I mirror to the other side, and another 3 holes. Okay, that's all for this part. The next part, which is the ring shell handle, it is used to hold the ring shell frame. So I use extrude to create this hole and use fillet to smooth the edges, and then also cut a hole for this. Also use fillet to smooth the edges. So here is the sketch. So I will turn on the visibility, then you can see that. This is the sketch and this is radius. I use center line to create. Okay, that's all for this part. Okay, for the ring shell holder, I use revolve. Why? I just sketch like this. And then I use revolve to create a hole holder, and then extrusion for this and this pin, and extrude the holes and fillet the edges. So that's all for this part. Okay, for the real tire, which is at the behind one, first I will create a sketch for the center one. Here is the sketch and I use revolve to create it, and then I will extrude some holes on it. Here is some holes. I use circular pattern, so I only create one and then I circular it. And also same as here. And how I create this tube inside it, I use 3D sketch. So I will enable the visibility and you can see that. It is created from sketch and then sketch from here, from the other side, pass through this surface or solid and then go through the rim. This is the rim and pass through it, and here is the dimension. Okay, and then I use swap also to create. So you can see that here is the 3D sketch I pick, and then the sketch at here. The sketch is located at here. So I did it once and then I use circular command to perform the other one. Okay, that's all. And how I create this part, which is connected to the chain. Also, first I start a sketch. Let me find which. Okay, how I created this part. First, I will start a sketch. Not this sketch. Okay, you can see that. this is the sketch. Okay, I sketch first, then I revolve, and then I use the revolve command. Use the revolve command to create a circular pattern, and then extrusion to cut the. This is a circle, so you can see it has radius. This is the circle. I cut once and then use circular pattern to create another one. Then fillet the edges and also fillet the edges. Okay. And the rim also created by start a sketch and then revolve. Okay, for the tire also using the revolve command, and you can see this sketch, and not this sketch, and you can see this sketch. Turn on the visibility. Okay, then I use revolve to create the circular tire. And now I will show you how I created this tire pattern here. So first, also the same, start a sketch. So I will have a work plane here. Okay, work plane, I turn on the visibility. It is located here. So okay, then I start a sketch. Here is the sketch. Only sketch on one side. The other side I use mirror. Then I use extrude. So extrude to this surface. I already created one surface inside the tire, so I extrude into the surface. Then OK. Then for the other one, I use circular pattern command to create all the other one. Then last, I use mirror to create the other side. Okay, that's all for this part. Now I would like to move on to the other part. For the next part, which is the rivet. Okay, this rivet is very simple. Just start a sketch and then extrude it. Also extrude from here. But these edges I use chamfer. Okay, you can see that I use chamfer. Okay, chamfer 45 degree with 1 mm and OK. Okay, same for the other side. So it is very simple. Okay, move on to the next part. Okay, for the next part, which is another rivet, but it is shorter. I think it is 8 mm. Yes, 8 mm. So it is the same. I also use chamfer to create these edges. So nothing different. Also use extrusion and then mirror it. Okay, that's all for this part. Next, for the shader, I created by using 3D Sketch and 2D Sketch. So combine both of it. You can see that this is the how I created. I use loaf. So first I will create the profile first, second, third, fourth, fifth, sixth, and the seventh. And the last one is at here. Then I use loaf, pick all the profiles. You can see in here. Pick all the profiles and the edges line. These outer edges. Okay, and here, and here, yes. These three outer lines. And OK. Also the same, I only create for one side and the other side I mirror it. And last, for the tube, it is very simple. Only use extrude and then create a holes inside here and fill the edges. Yeah, remember to fill the edges with radius 7 here, also same as here. So that's all for this part. Okay, now I would like to show how I create a sprocket. So first I create a sketch and use revolve command. This is the sketch. So you can see here it's not flat. There got some angle here. Okay. Then I use extrude to cut off all the holes. This is the circle with radius. Okay, here's radius 10. Also the same. I only create one and the other one is circular pattern. Using this circular pattern command. Also same as this small one. And I cut as the same. This is a circle. And I use extrude, cut once, and I also use circular command to perform the other one. Okay. And then for here is just simple, only use extrusion to perform it and fill the edges, and this is using loft. I will show you, and this is the sketch, visibility on. Okay, and then I will turn on the section view, arc section view, and then origin, and then okay, you can see that here is the center line, and I pick the circle which projected from here to create the loft. So the loft have two sketches. First is here, and the second one is the end. The end is located here. Visibility, loft, make visibility. Okay, the second circle is here, and the first circle is here. So it will create a loft. So fill the edges. Then that's all for this part. Okay, move on to the next part. For the stand, this stand is used to support the Trishaw when it is stationary. And also the same, I start a sketch, and then how I create the pattern here is the same. I start the sketch. Okay, now I turn on the visibility and you can see that how I create a sketch. This is the circle. This is two circles, then I use tangent, which the constraint. Use the tangent to constrain the both circles, here and here. And then the thickness is 2.5. And the circle will tangent with the frame here and here. Then I only create one side. The other side I use mirror. For the center it is more simple, only create one circle and a triangle inside, and fill the edges. And I think that's all. Created a hole at here for the river to insert. Then that's all for this part. Next, this is the tire cap, which is used to tighten the tires at both sides of the Trishaw. So here is a real thread inside, and then I use this fish draft to create these edges and fill out the edges, and mostly it is using extrude to create the whole part. Okay, that's all for this part. Okay, move on to the tires. It is same as the real tire, just the difference is here does not have the gear wheel because it does not connect to the chain, only the real tire connect to the chain. So how I perform to do these tires is also the same as the real tire. Okay, so also using 3D sketch to make the tubes, revolution to make these center tubes, then swipe to create the tube, also the tire pattern using extrude. There's nothing different from the real tire. The step to create this tire is same with the real tire. That's all for this part. Now for the wheel holder, it is in between the wheel so that the wheel does not moving around from left to right or from right to left. Okay, also the same, I use revolve. Why? Because I only create this sketch and then I revolve it around the axis. Then I will fillet the edges, and this is created by extrusion. This is all the extrusion. This is the sketch, and then it have a hole in the hole inside here. Okay, that's all for this part. Okay. And the last part is the wheel support pin. It is very simple. So it's just using extrude to create the cylinder, and then I create real thread for here and here. So it is very simple, and here is all the parts. Now I would like to move on to how I create the assembly. Okay, now I would like to share the most difficult part in this assembly. So first, I think to constrain the inner chain, outer chain with this sprocket is the most difficult. Okay, first, I will create a surface. I name it as chain surface. Okay, here is the dimension. Turn on the visibility. Here is the dimension. Why I don't did this surface in this assembly file? Because we can't extrude surface in the assembly file, which means like this. Okay, if we pick extrude, we can select face. We can select this surface mode, but we can't select in the assembly file. So we need to create another IPT file in a separate file from the assembly file. And then we place this surface in the assembly file. So I already create for the surface. This is the surface where the chain will move. Then I close this IPT file. So I already suppress some of the components so that my Inventor does not load much of files. Okay. This makes my computer more smoother. You can do it by right click and then suppress and OK. Then your part is suppressed. Okay. So first I will place inner chain and outer chain. So inner chain and then outer chain. Open and place and Okay. And then we will activate the surface origin and the outer chain and inner chain origin. Okay, first we pick constraint, and then this is the YZ plane, and we pick with the surface YZ plane. Apply. Let's see where it goes. Okay, where's my outer chain or inner chain? Okay, it is located here. Okay. Okay, I already grabbed to here, and then I use constraint again. Traditional. First, pick this surface, and then pick here. The arrow is downward. Okay, then apply. Next, we constrain the YZ plane of the outer chain to the inner chain. Then apply. Okay, then we grab it up. Okay, then we constrain. We will constrain the center of the circle to the center of the circle, which is here, and apply. Traditional. For this surface and this surface, and apply. And now I would like to show how the inner chain moves and get contact with the sprocket and turns the sprocket. So first, we pick this inner chain and pick this sprocket, then contact set. Then we go to inspect active contact set. Now, when the chain get contact with the sprocket, it will move. Alright, you can see right here, when the chain get contact with the sprocket will move. Now you can see that when the inner chain get contact with the sprocket will move. Okay. So the process is repeated for the inner chain and outer chain. It is the same until the whole chain is complete. So I will show you the complete one. So I open. And then assembly. Which I saw assembly. Okay. Okay, here is the complete set of the chain. All the inner chain and outer chain is connected from here to here, all around the gear. But I do not activate the contact set for this assembly because it is too complex for my laptop to perform the calculation. Why? If we activate the contact set, when the first outer chain contact with the sprocket, it turns the sprocket, and then the second outer chain get contact also with the sprocket. So it is much calculation for my laptop to perform. Okay, this is the whole assembly and it is done. Now I would like to show the isometric drawing for this assembly. Now for the overall dimension, my trishaw is roughly 2.3 meter length and 1 meter wide, and last 1.3 meter height. Okay, now I would like to make a demonstration how I create a real thread. So I use M6 mode as demonstration. First, same, we create a thread and pick this surface and then through all, then OK. So this is not the real thread, this is only the marking, right? Then I go to the tab Cool Orange, Thread Modeler, and pick this thread and then OK. This plugin will help us to create a real thread. And then I will show you how to get this plugin from Autodesk App Store. Okay, next, you will see this is the real thread. It is very simple and easy for us to do thread. And last, how I make the feature. So first, we need to combine the solid and this thread and then OK. And then only in that we can extrude the feature here. So start a sketch, then circle for 4, diameter 4 and diameter 10, then finish sketch, and then extrude, then pick this, cut, -45, and OK. Here you are. This is very simple. Now I would like to share with you how to get the thread modeler from the Autodesk App Store. Okay, now we go to Google and search Thread Modeler Inventor 2022. Then you will see Inventor Autodesk App Store. Then you will reach here, and here you can download the Thread Modeler. Yes, by clicking this download button. But here I got mentioned is support for Inventor 2020 only. It is not support in my version, which my version is 2022, which is the latest version. So you need to make some changes in the file. So I go to CAD forum and I search for the thread modeler. So the plugins are not supported for 2021 and 2022, but you can make changes in the notepad, change the series max from IR24 to IR26, save the file, and then change the string from 25 to 27. And the plugin will work on Inventor 2022, which is the latest version. Like here, you can see Cool Orange, Thread Modeler. Okay, we also can get support from the Inventor community. So here is the forum, Inventor forum. Any problem that we face can find the support from here. This forum already helped me much, and the CAD forum also.
In conclusion, I learned many things from this mini project. I would like to thank my lecturer, who is Engineer ABDULLAH, for giving me this opportunity. Last, I would like to invite you all to enjoy the assembly animation before the videos end. I'm Chin Hong, thank you.